Okay, this is actually one of my favorite days of calculus because it's kind of fun. It's kind of like a puzzle. And I'm going to open up a huge door of ways to integrate different functions. And this basically kind of takes care of, like for derivatives, we have a product rule and a quotient rule and a chain rule. For integrals, we don't really have any of those rules, but this method is going to allow you to kind of compensate for all of that. And what we're going to do is we're going to integrate using substitution. And I'm just going to kind of work through the first example to show you how it is, and I think you'll kind of catch on pretty quickly. But what we're going to do is we're going to let, if there's something that's basically in order to integrate number one using the power rule, which is really the only way that we know how to integrate, we'd have to FOIL out the x squared plus 1 quantity squared, and then we'd have to distribute the 2x. Does anyone really want to do that? No, absolutely not. So what we're going to do is we're going to use substitution. And for some reason, u is the variable of choice when we substitute a variable. You're always going to let u be something that's inside parentheses that's being raised to a power, or maybe under a square root or under a cubed root or something like that. So in this case, what's inside the parentheses that's being raised to a power would be x squared plus 1. You do not include the power. It's just what's basically inside the parentheses. And then we're going to take the derivative of u. Well, the derivative of u we're going to write as du. And then what's the derivative of x squared plus 1? 2x. But I'm going to write dx to signify that I've taken the derivative of in terms of x. Okay? Another way to think about it is if I'm taking the derivative of u equals x squared plus 1, I'm taking the derivative of u with respect to what variable? X. So you could think of it as du dx equals 2x. And then I just cross multiply so that I've got du equals 2x dx. But you can kind of skip that step if you just want to write du equals 2x dx. All right, so now we're going to substitute. The x squared plus 1, I let be u. And that needs to be raised to the second power. Well, conveniently enough, what does 2x dx equal? Du. So now, yeah, whoa. So now I have an integral that's completely in terms of u, and that's what the goal is. So what is the integral of u squared? 1/3 u cubed plus c. Okay, good. Now, you can't leave your final answer like that because the original problem was in terms of x's, but what does u equal? X squared plus 1. So 1/3 times x squared plus 1 cubed plus c. Okay, where did the du go? When you integrate, du is basically just telling us that u squared is the derivative of something. So when you figure out what the integral of u squared is, the du goes away. It's kind of like when we first started integrating, you would be asked to integrate x cubed dx. And the integral of x cubed is 1/4 x to the 4th plus c. So when you actually do the integration, the integral symbol and the dx go away. This 2x dx equals du. So I substituted it. So now my integral is just in terms of u. Her comment was that, is that just chance that 2x dx exactly equaled du? I started with a really easy example. We'll be able to manipulate it a little bit in order to make sure that it all fits together. So good lead into that. Okay, with trig functions, if there's just a single trig function, you're going to let u equal the argument. So what's the argument on 5 cosine 5x? 5x. All right, so if u is 5x, the very next step is to take the derivative of u. So du would equal 5 dx. Good. All right, so let's try and substitute here. It's not written in exactly the same order for it to be so obvious that the substitution works, but the cosine 5x that part right there could be written as the cosine of u, and then I do have 5 dx, which is du. Okay, so the 5 and the dx are not right next to each other, but it's all multiplied together. So if I really wanted to, I could rewrite this integral as cosine 5x times 5 dx. And it all fits. Okay, well, what's the integral of cosine u? Sine u plus c. Very good. And since your original problem started with x's, we have to end with x's, so it's the sine of 5x plus c. I'd like for you to get in the habit of writing that step down because these are pretty simple examples. What do you get when you take the derivative of sine 5x? The derivative of sine 5x would be cosine 5x times 5, which is what we originally started with. Okay. Let's look at number 3. 3 is we're going to have to deal with what Sophia was talking about. If the rule is to let u be something that's raised to a power or perhaps under a parenthesis, or under a square root, which really something under a square root is being raised to what power? The 1/2. Okay. What would it make sense to let u be? Okay, x squared minus 2. And therefore, du is 2x dx. All right, so if I rewrite this, or if I start substituting in for my u's, the square root of x squared minus 2 would be u to the 1/2, or the square root of u. But all I have here is an x dx, whereas du is 2x dx. I could divide by 2, or you can stick a 2 inside an integral as long as you compensate by multiplying the outside by a 1/2. That's one of your properties of integrals, is that you can pull a coefficient, a number, in or out of the integral. So I'm really just multiplying by 1/2 times 2. So I have this 1/2 outside the integral, and then therefore my 2x dx is my du. Everybody okay? Okay. All right, so when I integrate, what's the integral of u to the 1/2? U to the 3/2 plus c. I went ahead and put the 2/3 u to the 3/2 plus c in parentheses, but when you distribute this 1/2, you're going to get 1/3 u to the 3/2 plus 1/2 c. And what can you tell me about 1/2 c? It's still a constant, right? So you don't need to worry about that. And then I just need to plug my x's back in. So 1/3 quantity x squared minus 2 to the 3/2 plus c. All right, let's look at number 4. What do you want to let u be? Y'all are so good at this. Is there going to be a trick about what to set u equal to? I wouldn't say there's a trick, but as we do more and more of these, experience is just going to help you out. Okay, so what does du equal? All right, so if du is 2 dx, then I'm going to need a 2 in there with the dx, right? All right, so I'm going to stick a 2 in there, and how do I compensate outside? 1/2. Okay, what about the x? That's the big question there. What? Okay, you cannot pull a variable in or out of an integral. I know, that would make it really easy. If u is 2x minus 1, Okay, Tamar's got it. If u is 2x minus 1, what would x equal? U plus 1 over 2. Okay, so for the x, I'm going to put in u plus 1 over 2. And then my square root of 2x minus 1 is u to the 1/2. And the 2 dx is my du. Isn't that kind of fun? Way to make it work? Okay, Gray, what was your question? Since du is 2 dx, I stuck a 2 in to get my du okay, and therefore I had to do the 1/2 outside. All right, now this is my suggestion. We're going to have to do a little bit of simplifying before we actually integrate here. My suggestion is, isn't this u plus 1 divided by 2? That's the same thing as 1/2 times u plus 1. And then I've got the u to the 1/2 du. That 1/2 inside can be pulled out. And really, I kind of like to pull out any coefficients because I think it makes integrating easier. So if I pull the 1/2 that's inside out, what do I have outside now? Good. So 1/4 integral. And then what else do I need to do inside in order to integrate it? Distribute, right. So u times u to the 1/2 is u to the 3/2 plus u to the 1/2 du. So I kind of did two things at once there. I pulled that 1/2 out and distributed the u to the 1/2. You do not have to pull the 1/2 out, but I think that it would be, I think it's easier to integrate u to the 3/2 than it is to integrate 1/2 u to the 3/2. Sophia? Because when I pull the 1/2 that was on the inside out, I would multiply it by the 1/2 that's already out there. So 1/2 times 1/2 is 1/4. Okay, so let's integrate. Well, there's only one 1/2. There's only one 1/2. Yeah, you don't distribute when everything's multiplied together. You don't distribute. You wouldn't distribute the 1/2. Sophia? Up here, my du was 2 dx, so I needed a 2 to compensate for the du, and therefore I had to put a 1/2 outside. But then this 2 dx was substituted for the du, and then when I brought in my x, that brought in this other 1/2. All right, so when I integrate u to the 3/2, I get 2/5 u to the 5/2, and plus 2/3 u to the 3/2, plus c. All right, can I distribute the 1/4 and plug in my u's at the same time? You all cool with that? All right, so 1/10. 2x minus 1 to the 5/2 plus 1/6 2x minus 1 to the 3/2 plus c. And really, guys, with becoming successful at this, experience is your best friend. Experience and practice, because the more you see of it and the more you do of it, the quicker when you see a problem you're going to recognize, oh, I need to let u be this, and I'm good to go.